But not everything operating by natural selection, as I mentioned previously. There's also random process known as genetic drift. And this you probably already learned it from your evolutionary biology. So this couple of slides just show you if you start with the equal frequency, 0.5 and 0.5. So this is a sort of like an illustration of the changes over time. And the process goes through a random process. As you have a gene pool, have both alleles has at the 0.5 proportion. And you sample alleles from here to form the next generation. So everything here just to show you the numbers, and it's not really very difficult. So every time I will form a gene pool based on the frequency of the previous generation and do a sampling. And the way I do a sampling, I just like randomly pick a number to assemble the next generation. But the important part is to tell you, you can look at from 0.5 to 0.6, then 0.8. It was like, oh, the frequency is increasing. But by genetic drift, the chance for increasing or decreasing are not based on the trend of the previous generation. Every generation is an independent event. We only can calculate the probability of certain frequency in the next generation. Just try to mention about that. I should pick up number at the generation 2. We can go from 0.8 to 0.4 within one generation just by chance. So this is just try to tell you in the genetic drift, it's everything depends on the random process. The frequency of allele could fluctuate from generation to generation. Of course, if the frequency at 0.5, there's a higher probability you get frequency around 0.5 in the next generation. There's relatively low probability you get a frequency at 0.1 in next generation. But that's the probability distribution. But if things happen, especially in a small population, if things happen, you only get one allele in the next generation, then the allele is fixed. So that's the random process. So this is the formula. We calculate the probability of one particular allele happen in the next generation. So we still calculated 2n gametes, and you sample from a gene pool. Then you want to calculate or estimate what would be the potential frequency or the probability of the allele I in next generation. And this is, go back to your combination, and let's go to I factorial times 2n minus I factorial, and the denominator is 2n factorial. So this probability then times to the P and Q frequency, and to the power of I, or 2n minus I. So this is to talk about what's the probability if we have the A1 allele in a given population size, and what's the probability we will get an I type, like a number of I alleles in the new generation. So that's the calculation. And usually we get a probability, but I say the probability to predict if I can get, say, 0.5. What's the probability to get A1 at the frequency of 0.5? Or what's the probability of A1 at the frequency of 0.4 and frequency of 0.3? So you get the probability distribution.